Welcome to Techstination. Joining us is Christian Weedbrook, the founder and CEO of a company called Xanadu. Thanks for joining us, Christian.
No problem. Thanks for having me, Fred.
Well, you're a Canadian company, a leader in photonic quantum computing, and you've announced the release of the world's first publicly available photonic quantum cloud platform. I'll let you explain to us what that means.
Thanks, Fred. Yeah, it is a bit of a mouthful for sure, but it's an extremely important day, not only for Xanadu, but we believe for the wider quantum computing community as well. Essentially, the way to think about this announcement is go back to what we do know. So we do know AWS and Azure and cloud computing is a big thing, and really that allows people to log in from anywhere around the world and use their computing power. Well, the same thing applies here to the Xanadu quantum cloud. Wherever you are around the world, you can sign up and log in and have access to photonic quantum computers, quantum chips, silicon photonic chips, which is really exciting. This is a world first. No one's actually put a quantum photonic computer on the cloud anywhere in the world, and we're really excited about it.
Well, describe for us what photonic computing is, quantum computing.
Yeah, maybe one place is to sort of unpack quantum computing. So essentially a quantum computer is a new type of computer that runs on different laws of physics. So before quantum computers, every other computing device ran on the physics of traditional physics, Newtonian physics, as it's known. But now this new phase of computing leverages properties of quantum physics, really crazy things like entanglement and superposition principle, which you may have heard of, which superposition principle tells you can have, instead of two bits of information, 0 or 1, you can have both at the same time. And it really leads to this exponential type of power. So what that means is you can actually now have a photonic version of this. There's other types of quantum computers out there that essentially the electronic version, the quantum version of electronics. We've taken a different route that's using light or photonics. So think fiber optics, beam splitters, phase shifters, things of that nature. And we've built a quantum computer out of that.
So it's using light, basically, is what you're saying, to send the data.
Exactly. Think of laser beams. That's probably the best way to think about it. And using these laser beams, we can manipulate them in a certain way to extract these really cool, interesting properties of quantum physics.
So how do you apply this? What is done then with this with your customers? What's the process?
Yeah, that's a good question. So the key thing here is customers now have choices in quantum computing. It's a fascinating time to be part of this industry. So you have not only the Xanadu cloud, but others. Now, the reason why you'd like to use the Xanadu cloud is you have a different set of applications for customers that are not available on any other cloud platform. So kind of think of it as an app store, but you can download all these different types of apps. Now, it's a very early part of the industry. This is going to be transformative, and one of the things is it's going to affect finance, it's going to affect pharma, it's going to affect all sorts of industries, material design. So customers from those industries, the early adopters, they'll be using our platform to really understand how the platform works. So once we scale up to meaningful problems, they're ready to take advantage. It's a very hard technology, but we're on the cusp now of really scaling up to meaningful problems to be solved over the next couple of years.
And are your customers primarily corporations, academia? Who are you working with?
Yeah, we're working with all those. So it's really, where are the early adopters? Where are the people that really know about quantum computing and the scientists associated with that? So like you mentioned, large corporations, pharma and finance, two good examples there. Also, you can think of government labs in the US and here in Canada, and also universities as well. These are where the real people that understand quantum and can really take advantage of it.
Now, everyone has heard of the big mainframes over the years, the supercomputers at IBM like Watson and whatnot. Are you tackling the same kinds of problems that they've publicized there?
Yeah, I would say those, fascinating large computers like Watson and all these supercomputers, they're still normal computers, although, very much more powerful than the computers we have at home. Quantum computing is really throwing away a lot of that way of doing computing And we can unlock problems, not yet, but in the future, this is the promise of quantum. We can unlock problems that actually cannot be unlocked even with the world's largest supercomputers. So a good example, with drug discovery, it takes over $1 billion to find a new drug from end-to-end process. And a lot of this is about how do you simulate, what sort of drugs are the best to actually synthesize. There's a lot of trial and error, a lot of heuristics with these sorts of developments. But in principle, a quantum computer can speed this up, taking things that may take years to, in principle, a couple of months. So pharma is a great example. It's wherever there are tough computational problems that are at the heart of what customers are trying to solve. So pharma and finance are two great examples.
Right. And obviously, in the situation that the world finds itself in today, the sooner we get this plugged in, the better, it sounds like.
Exactly right. The key point is you read a lot about the media, and it seems like, the most powerful type of quantum computer is available today. That's not true. But, we're on that path. So even though quantum computer is not going to provide any help today, say with COVID, the real hope of quantum computing is in things like maybe future pandemics where we can actually use a quantum computer that can simulate these types of candidates much, much faster. So, there's talks of maybe having a vaccine end of this year, early next year. If we could speed that up by 6 months, the world would be off in a lot better place.
Now, how expensive is this for your customers in comparison to using other types of computing?
Yeah, I would say, compare it to what traditional quantum cloud computers are offering at the moment. So it's fairly inexpensive. So there's other cloud providers along with us. I would say it's cheaper than traditional computers. It really depends on what problem are you trying to solve. But for us, the early adopters, as I mentioned before, they're willing to pay these prices and have a lot of cloud time because they really see the transformative aspects of this computing platform, and they know that if they miss the boat now, that's going to be a high cost later on. So it's a good way to start saving money now.
And is it going to be a crowded space, do you think, or are the barriers too high?
Well, that's interesting. You can actually, it feels so crowded now. We started 4 years ago, and there was very few people. Now, if you look at certain sites, there's probably 50 to 100 quantum companies. I would say you can break these companies down to the ones that are providing hardware and then separately the ones that are providing software, quantum software. Now, Xanadu is great. It's one of the unique ones that does both. But the barrier to entry you talked about, it's much easier to start a software company, whether it's quantum or classical. You don't have to pay for the large overhead of the hardware and labs and so forth. So you're seeing more and more companies populating that area. You are seeing a few more in the hardware space, but it's less so. I would say it's dramatically different from the software side.
Really interesting. And in terms of getting people to be able to program, to make use of the quantum computers, are there issues with that? Is it different from traditional programming?
Yeah, it's fundamentally the theory is extremely different. It's also, at the same time, very fascinating. What we've done at Xanadu, our main software product is actually called Penny Lane, after the great Beatles song. And
watch it
you
all
can
sing.
think of that as I know now you're tempting me. Maybe we could do the chorus together later on. But it's it's a famous song, obviously, and we're really inspired by the Beatles, or just in general greatness. But you can think of Penny Lane as being the TensorFlow for quantum computing. TensorFlow is really for developers that can develop AI algorithms, non-quantum algorithms on GPUs without having to worry about how does a GPU work. And we've done the same thing. So it is fundamentally understanding the theory behind this. The software is complex, but we've abstract all that away, and developers can start using Penny Lane and also our cloud platform using, say, already pre-existing languages such as Python, for instance. So if you know Python, then you can actually just start using it straight away. It's a very fascinating thing to do, and knowing that you're actually part of a new type of computing landscape is extremely exciting.
For more information, where can people go?
Yes, please go to Xanadu.ai, and you can see all about our hardware and also all about Penny Lane and other things that we're offering at the moment.
And again, that's XANADU.ai.
Correct, that's right.
Christian Weedbrook, thanks for taking the time with us.
No problem. Thanks again, friend.
Now this. How many companies out there have continued to innovate when it comes to building a better radio? I'm Fred Fishkin, host of Techstination, and I'm here to tell you about the new CC Skywave SSB radio from the wonderful people at C-Crane. Bob and his crew really love radio, and it shows in this new compact model that is packed with features. Beyond great AM and FM reception and sound, you can tune into shortwave signals from around the world, listen to ham radio operators, aviation, and more. It's the radio you'll turn to every day, and in emergencies. It will run for nearly 3 days on just 2 AA batteries. Pair the sleep timer with the new Soft Speaker 3, and you've got the perfect radio for your nightstand. Of course, it can wake you up too. Click on C-Crane at Techstination.com and put in the code Techstination for a free flashlight with your order. They love radio, and you'll love C-Crane.